Okay, so we're going to talk about trig ratios. These are trig values, but today all these trig values are going to be in fraction form, okay, because trig values can be numbers, decimally numbers, or trig values can be fractions as well. Okay, so here's what we're going to do. We're going to draw this coordinate, 3, 4. Can you draw it for me? Think about what quadrant you got to be in. Okay, 3, 4. So I drew that coordinate. Basically, I really just have to think about what quadrant I'm in, okay? Now I'm going to draw an angle arm that goes through that. An angle arm is going through that coordinate, okay? So where do we always connect angle references to? Which spot? The x-axis, okay? Which means I'm going to form a triangle there. I don't want you to triangle it up here because that's connecting to a y-axis. Okay, and this triangle is indeed a right triangle. So your brain can go back to grade 10 if you want, because that was grade 10 trig, right? Right triangles? Okay, so I know the length of this wall of the triangle. It is 3, and I know this one, 4. So is there a possible method that we know from a past to get the last side? A squared plus b squared equals c squared. So that adds to 25. Is that rootable? Yes. So that side is 5. What do you know about this diagonal side? It always has to be something specific. The longest, yeah, that's exactly what I was looking for. It always has to be the longest side, no matter what, right? Okay, so we're going to get the trig ratios, and I'm going to show you maybe how your grade 10 brain can do it, but I also want to show you moving forward kind of where I want you to go with it instead. Okay, so grade 10, you learned this. The sine of the angle, and you use SOHCAHTOA stuff, remember? Equals. So from this angle, which side is opposite? 4 is opposite. And which side is the hypotenuse side? 5. Okay, does that sound familiar? SOHCAHTOA, opposite hypotenuse side. Cosine of an angle, so I'm always going from this spot, right? Is the adjacent. Where is the adjacent to my finger angle? 3, and the hypotenuse 5. And TOA. Okay. Now, great, that's how we develop them, okay, but moving forward, these are on your formula sheet, okay, and basically all the trig stuff really makes us think in this way instead of SOHCAHTOA way, but that's how it comes about. Okay, so would you also consider this adjacent side the x value? Does that make sense? Because it's the flat side. The vertical part will always be the y. And this is called the r. And what do you think this r is going to maybe represent in this scenario? What's a word that starts with r that comes out from the middle to the outside? Radius. Okay? So it's like if I could draw an imaginary circle. Okay, the radius would be 5. So radius. Okay, the radius is always diagonal. Okay, so here we go. Sine theta equals if I use these formulas, what's the y value of the coordinate? 4. And we knew the radius was 5. If I use the formula, x is 3, and our radius was 5. Okay, so it is the exact same thing, but these formulas were developed because of the SOHCAHTOA stuff. Okay, here's a little trick that I tell my grade 12s so that they can always remember these. Okay, if you forget them, in grade 12 you have to memorize them. Okay, but grade 11 they're on your formula sheet. But you will probably get familiar with them. This is my little thing. So, you're really cute. X-rated. Thank you. Excellent. Okay? And then they always kind of remember the flow of it. But really, it's just so, ka, and toa. All right. Let's go to this little corner here in our sheet. If we're in quadrant 1, we just did this one. This wall is positive. This wall is positive. Guess what? Your radius, always positive, no matter what. What would your coordinate look like in quadrant 2? This x wall is going to be negative, positive, always positive up here. Always the positive diagonal. Always. Quadrant 3, what would your walls look like? Negative because it's left. Negative because it's down.
But the radius is
always positive radius. Always a positive radius. And then in quadrant 4, when you do the walls of that triangle, it will be positive, negative, always positive. Okay? So that's going to come into consideration, okay? And that's just your coordinate stuff, okay? It makes sense where your coordinates are. Okay, so let's try this out. We're going to go through -5, 3, so we have to think about the quadrant we're in. -5, 3, where's that coordinate going to be? So did you draw your angle going into quadrant 2? Does that make sense? Okay, so when I connect my triangle, I'm making sure I'm making that x-axis reference connection. Okay, I'm going to label the walls. So -5 is an x value, so it's got to be on the flat side. 3 is vertical, y. And I'm going to figure out the r. Okay, so do you remember what I talked about with that trig value inversing thing? I always said don't put the negatives into your math, into your calculator at all, because the negatives are just location things. So you're only going to go 3 squared plus 5 squared like that. Do not touch the negative. It's not involved in this distance, okay? The triangle values are all about their distance values, okay? The negatives is just a location thing. It's not a math thing. Okay, and this is kind of going to go for all this trig stuff. What am I at here? 9 plus 25, that's 34, right? Is that a nice square rootable number? No. So, I have to just leave it. I don't want to decimal it. I'm just going to leave it alone like that. Okay, so now get me your 3 ratios. Sine. So here I go. I'm going to go my y value, 3, r value bottom. Cos needs to be my x value, then my r value, or ka, whatever, that also, right, is lining up. And tangent is to a. Okay, I'm just going to make a suggestion. I'm not going to mark this wrong, but often when we do fractions, I don't write negative like that. I just go -3/5. Okay, this is not how math likes to write fractions with a negative bottom. They just like to say -3/5. Okay, I'm not going to mark you wrong, but it's just not mathy. This is a better mathy way. Hey, let's check this out. Remember when we were doing Astica? We landed in this quadrant with the S part. What does this tell me about these things? When I'm getting a sine trig value, it has to be positive. Cos better be negative. Tan better be negative. Look at that. See, it's all going to fit. Okay, 2 more questions for the day. Okay, so this one is a little different in the sense that I start not knowing where I am. So we're going to figure this out with the info. So this little information is telling me sine has to be negative. So what are some options for my Astica spots? Bottom sine's negative. And then it's giving me another hint that cos is positive. So let's think about Astica. I could be on the right. So, which quadrant now? I have to be in quadrant 4. All right, so I'm going to draw myself. I don't really know where exactly. I'm just going to draw 4. Quadrant 4, I'm going to connect my triangle to an x-axis like that. Okay, so this is the given information. It's not a coordinate, it's just a sign. So what is this representing? An X, a Y, an R. What does the sign mean to do? What is this one? A Y, and this would be a R. So now I can put that on my triangle. R, the Y and the R, they can be on my triangle walls now because I figured out where they need to go. Or the so opposite hypotenuse. Okay, so this is a little different because this is now not finding the R, I'm trying to find this wall. So how do I find this? Backtrack. A squared plus B squared, but you got to backtrack, so we got to go 5 squared subtract 4 squared. Okay? Don't even think about -4. Just distance 5, distance 4. So 25 subtract 16 is 9. Is that nice square rootable? 3. So this wall is 3. But here's now what you have to do. Is it positive or -3 based on where I am? Positive. It's an X value, right? Where are you? On the left or the right side? Why didn't I think about that before? Because in these examples, we were figuring out R, and R is always positive. Okay? Finish this out. What's the fractions trig value for cos? (3/5) XR or Ka. And what's the tan's trig value fraction? YX or TOA? Hey, did your answers fit into your Astica? This quadrant, do you have a cos value that's positive? Check. Are the other things negative then? That works, right? Okay, last question. And it's the same idea as this number 3. We're going to do it one more time. Okay, so the first thing is I actually didn't get the quadrant info out of this. So cos is negative. Sine is negative. So my final location to make sure both our things are happening, quadrant 3. Okay, so I was told the cos. So out of these 3 walls, there's a wall that has a -4 on it and a wall that will have a 7 on it. So figure that out. Where would you put the -4 and where are you going to put the 7 according to the ratios? Okay, so I was going with the X and R. So that's why I put them into the spots I did. Okay, so that means we got to figure out the vertical wall. Pythagorean, backwards Pythagorean. 7 squared subtract 4 squared. 49 subtract 16, that's 33. Square rootable, not good. So I'm going to leave. When it's not a good one, you leave. Square root 33 on that wall. But what kind of number is that? You have to think positive or negative. If you're getting to an X or Y value, you have to know if it's positive or negative. Okay, if you're getting an R value, you don't have to think about it, it's positive. So what kind of wall do we want here? I want a negative on that wall, right? Okay, so sine, tan, we need to figure them out. So sine is going to be the Y side over the R side. Tangent is the Y side divided by the X side. Okay, my math in me says that is not a good way to leave this answer right here. What happens if you had 2 negative numbers? It's a positive value, actually. Hey, does everything connect to your Astica quadrant? Is the tan number that we gave positive? Everything else negative.